Alright. HT7 from the Get It Problems. Test 1 2016, question 6. So, got a picture. Gotta love pictures in physics questions. So here's picture. Monatomic ideal gas initially in a thermodynamic state I is taken through one of 4 possible processes labelled 1 to 4. There's 1, goes to there, 2 to there, 3 to there, and 4 to there. They kindly give us a description of each of these. 1 is an isobaric expansion. There. Isobaric, the pressure stays the same. And if we look at that, we see that it gets hotter. How do we know? Because we see that isotherms are shown on the graph. And 400, 500, who knows what this one is, but it's obviously hotter than both of those two. How do I know it's hotter? Well, look, if I want to keep the pressure the same while I'm expanding it, the only way I'm going to do that is to add heat and make it hotter. It has to be hotter. Don't worry about why. Actually, because of PV equals nRT. That's why it has to be hotter. Okay. Process 2 is an isothermal expansion. Keep the temperature the same. There we are. Beautiful. Start at 500, finish at 500. Process 3, an adiabatic expansion. From there to there. Adiabatic, we don't add or take away any heat. Okay, so naturally the gas will cool in an adiabatic. So therefore we drop down from 500 to 400 Kelvin. And process 4, an isochoric cooling, taking the gas from I to D. There it is. Isochoric, keep the volume the same. So if we're going to keep the volume the same and we're cooling it, clearly the pressure must drop, and that's what we see there. Okay, so what is the actual question? It says, it gives you also the adiabatic constant for a monatomic ideal gas in case you need it. It says rank the processes 1, 2, 3 and 4 as shown above according to the change of internal energy of the gas greatest first. Now internal energy is basically temperature, isn't it? Hotter, higher temperature, greater internal energy. So therefore what we're actually doing is ranking in terms of temperature, because in an ideal gas all of the energy, internal energy, is kinetic energy, and kinetic energy is proportional to temperature. So let's have a look at them. So this one starts at 500 and ends up hotter. So this has the most internal energy. This one starts at 500 and finishes at 500. So this has the second most internal energy. These two both start at 500 and end up on the isotherm for 400. So they both lost the same amount of internal energy. So here we have an increase in internal energy, here we have no change, and here we have 2 decreases that are the same. So rank them according to the change of internal energy. Well, that's a positive change in internal energy, so we need to have ones where 1 is first. Okay, then B is second, so 2 is second, so that's there and there, but this one says 2 is equal, but it's not, no. Okay, and then 3 and 4 are the same because they both lose the same amount of energy. Yep, there we are. That's the answer, see? Now these questions are so easy. Now, how easy was it? 47% said that. For some reason, 23% liked A. Not sure why. And it was around 10%. And 10% and 10%. So I think we can safely say guessing, 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 correct, not sure why. Okay, yeah, maybe just looked at the picture and said look, 3 is more than 4 because it goes across to there and that one. But you remember, internal energy, temperature, goes from 500 to 400, so it's the same. Okay.